LDPC decoding. Actually, LDPC decoding is done with the help of a tanagraph through a message passing decoding algorithm. And we are going to discuss the message passing decoding algorithm uh, for binary erasure channel. That means we'll be discussing only the case where erasure happens in the code word. That is, in the code word bits being transmitted, some of the code words may get lost during transmission. So in this case, we won't be discussing the error situation where one bit may get flipped to another bit. So as I said, this is decoding is done with the help of a tanagraph, and the message passing decoding algorithm is an iterative algorithm in which all the variable nodes and all check nodes in parallel iteratively pass messages along their adjacent edges in different rounds. So after a particular set of rounds, the all the code word bits will be decoded correctly. And since this algorithm works iteratively, it is difficult to understand directly the algorithm. But so for simplicity, let's discuss a local decoding algorithm which take uh, one parity check equation or consider one check node at a time to fill the erasure or the bits being lost. So since this is a simple algorithm or the a local kind of algorithm compared to the message passing decoding algorithm, we call it as a peeling decoder. So let's try to understand the decoder with the help of an example. And let me consider this as the parity check matrix. So based on this parity check matrix, as I discussed earlier, um, this is the tanagraph corresponding to this particular H matrix. So you can see there are three rows, so three check nodes will be there. Since there are seven columns, seven variable nodes are here. And the connections will be like first row will be deciding the connections towards this first check node. So V1 plus, V2 plus, V3 plus, V5. So V1 plus, V2 plus, V3 plus, V5. And I haven't marked this V1 to V7 and C1 to C3 in this particular tanagraph. So let's see how this local message passing algorithm works for the decoding of erasures. So initialization step means it will start from the variable node. Of course, obviously it should start from the variable node because variable nodes are nothing but the code word bits being received from a particular channel. So uh, when the variable nodes receive the code word bits from the channel, these variable nodes will be transmitting this or forwarding the non-received values along the outgoing edges. And what this check nodes will do is it accumulate forwarded values at check nodes and record the corresponding parity. And the third main step is delete non-variable nodes and all outgoing edges. And we will see all these steps with the help of this example. And this is the diagrammatic representation for a particular received code word bit X. So suppose X is equal to 0, question mark indicates the erasure or bit being lost. So basically from the channel, this particular variable node don't know whether 0 or 1 being sent because the bit is an erasure. The second bit is an erasure, fourth bit is an erasure, sixth bit is also an erasure. That is why we have replaced those positions with a question mark. So the other things are 0 erasure, 0 erasure, 0 erasure. Last bit is 1. So first of all, first as mentioned in the previous slide, the first step is forward the non-values, that is obtain the values from the variable nodes to the check nodes. So these values will be transmitted to the check nodes, and the green line indicates the bits being received correctly. So let's assume that the bits those are obtained are received correctly, because we are not considering the error case here, only for erasure. So the green lines indicates the bits being intact, and the red line indicates the bits being erased or lost. So all the variable nodes will transmit those values, received values, to the corresponding check nodes, that is along the outgoing edges. And you can see the red and green. Since this is only one connection from this last variable node to this check node, uh, this one is being transmitted to this uh, particular check node, and it's indicated as blue line. Now the next step is accumulate. Second step I have mentioned is accumulate the parity at the check nodes. So the check nodes, what it does is, um, check nodes will be calculating the parity by adding the values received through its edges. So this particular check node, first check node, received 0 from this variable node, and from the second variable node erasure, third 0, and the fourth connection is also 0. So basically it adds all those values. So 0, 0 and 0, but the one of the connection is an erasure connection from this particular second variable node. So the check nodes will delete the non-variable nodes and its edges. That is, these green lines are those edges from the variable nodes whose values are already known. So we have to find out what the decoding does is, we have to find out this erased values somehow. And through this message passing, it is being done. And so the check node will delete all this green uh, connections from the variable nodes whose values are known, and the remaining connections are left out connections towards the check nodes are only from those variable nodes whose values are unknown, whose received bits are unknown. So next, what it does is, before that, let me explain the decoding step. Select, if possible, a check node with one edge remaining, forward its parity, thereby determining the connected variable node. So we have to, if possible, we have to go for a check node which is having only one edge with erasure, because it is easy to find that erasure bit. Delete that check node and its outgoing edge. Follow procedure in the initialization process at the known variable node. And how it terminates is, if remaining graph is empty, the code word is determined. If a decoding step gets up, we declare that it's a decoding failure. So let's see how we can proceed. So this was a situation like we were having all the green nodes. This was an erasure in the previous slide. And since all other connections towards the first uh, check node was removed, uh, this is a particular check node with only one erasure. And from all other received things, this check node knows that this is 0 plus 0 plus 0. So this is uh, the check node uh, will compute the value for the variable node whose bit is erased as 0, because it has to tally the equation. The equation should be correct. So basically the check node is expecting a 0 value as the sum of all the bits in the variable node, connected variable node. Since all the three variable nodes is having 0, if this bit is 1, that won't satisfy the particular check node equation, because this C1 is equal to V1 plus V2 plus V3 plus V5. And V1, V3, V5, we already know it is 0. So this should be 0. So this check node will transmit the value to the particular variable node. That is, find degree 1 check node. We have found a degree 1 check node whose one of the edges remaining with erasure. forward the accumulated parity from the accumulated parity sum of the values of the received from the other variable nodes, determine the variable node value which is having an erasure. So this we uh, we found it to be 0. So you can remove this also connection from this check node. Now from that, let's delete that check node and edge, forward new. We have deleted this. That is why it's black. Forward new variable node value. Now we can see the other check nodes. If you look into this third check node also, what happens is second check node, we have two erasure connections. So it's difficult to find. So when you look into the third check node, you can see only one erasure is after finding the second value of the second variable node, only one value is having erasure. So you can easily find this value by summing all other values received from the all other edges. So this is 1. This is now 0. The first one is also 0. So 0 plus 0 plus 1. So this will this check node will determine this value to be 1, because otherwise all the sum is 1. So this should be 1. So that 1 plus 1 is 0. That would satisfy this parity check equation. Because this C3 is V1 plus V2 plus V5, sorry, V4 plus V7. So in order to satisfy the equation, this should be 1. So this next, this check node will pass that 1 to this particular variable node and delete the edge. This is the same step that I have discussed. And the next step, I have shown that this is 1. Now, this can also be deleted. So this is the figure which shows this connection being deleted. So it turned black now. So now only left out variable node with erasure is this thing. So now when you look into the second check node now, you have to find only one of the erasure bit. The other values are 0, 0 and 1. So 0 plus 0 plus 1 is 1. So this should be 1 in order to satisfy 1 plus 1 is equal to 0 at C2. So this should be 1. So the check node will pass that 1 to that particular node. So this is the decoder code word 0001011. So this is the decoder code word 0001011. So if this x into x is the code word, if this is the decoded code word, then how can you find that whether the decoded code word is correct or not? By simply computing this code word into v into h transpose is equal to 0. Similar way, here x into h transpose should be equal to 0. Then only we can say that the decoded code word is correct. So this is the message passing decoding algorithm explained by taking one check node at a time. But this is not the exact algorithm. But this is easy to understand compared to the message passing, which iteratively pass messages from all the variable nodes and the check nodes parallelly, simultaneously. Okay. So when you are asked to um, explain the message passing decoding algorithm for LDPC code, you have to explain the steps mentioned from this slide onwards. So this is basically a local, local decoding procedure that we have discussed now can be described in terms of the iterative message passing algorithm, in which all the variable nodes and all the check nodes in parallel iteratively pass messages along their adjacent edges. So the values of the code bits are updated accordingly, and the algorithm continues until all erasures are filled in or until the completion of a specified number of iterations. It will go, there will be some pre-specified number of iterations. So if all the erasures are filled within the number of iterations, we will receive the decoder code. Otherwise, the decoding will stop, declaring that uh, it with an incorrect code word or decoding failure. So basically, the steps involved in the message decoding algorithm is there are only two steps, and this will be done iteratively. So you have to uh, learn what is the uh, um, message to be passed from variable to check note, which is the first step. Because as I said earlier, the variable nodes are nothing but the nodes corresponding to the code word bits being received from the channel. So when the variable nodes receive the code word bits from the channel, that will be passed to the corresponding uh, check nodes through the different edges. So how this which message will be passed by a variable node from to a check node is determined by these two steps. If all other incoming messages are erasures, send message v is equal to erasure. That means you can see from this diagram, this variable node is trying to send a message towards a particular check node. Remember, from a variable node, there will be so many connections towards different check nodes. And when this variable node tries to send a message towards a particular check node, uh, excluding that check node, that edge, it will check all other edges. If all other edges from this variable node towards different check nodes are erasure bits, then the message sent will be like erasure. If any other incoming message from the channel, let's take the incoming message as u, is 0 or 1, then send the message from the variable node to the particular check node as v is equal to that particular value u. And if the bit was an erasure, fill it with u2. If any other incoming message message u is 0 or 1. So here you can, from this diagram, here you can see that the message, this variable node is trying to send a message towards one of the check nodes, and all other edges are, one is erasure, other one is u. So if any one of the incoming, even one of the incoming messages, some 0 or 1, then this variable node will send that bit towards the particular check node. And if the received message from the variable node is also an erasure, it will be replaced with u. This step will become clear once we discuss with the help of an example. As I said, note that there are no errors on the binary erasure channel. So a message that is 0 or 1 must be correct. Messages cannot be inconsistent. So we are discussing only about erasures. Now, what about the check node to variable node message? Here, if any other incoming messages erasure, then u is equal to erasure. And if all other incoming messages are zeros or ones, send the XOR of them, u is equal to v1 plus v2 plus v3 as the message towards a particular variable node. You can see from this graph, like partial graph, like if this is the first case where if any other incoming message is erasure, the check node will send it as erasure only, send the message as erasure only. If all the other nodes are having other edges are having some values, then the check node to variable message will be the sum of all other values received. Okay, so you have to remember the check to variable message on each edge and variable to check message on each edge. And the same example I have considered here. So message passing example, initialization will be, first of all, as we discussed in the previous example, the same expression, same graph, same H matrix. So 0, erasure, 0, erasure, 0, erasure, 1. But this time the difference is just directly message passing algorithm, and all the variable nodes will pass the message simultaneously. Similarly, after that, the check nodes will pass the message simultaneously. So first, these messages will be transmitted to the corresponding check nodes. First of all, before that, you have to draw the diagram based on the H matrix. Now, this is X is the uh, received code word, which we are trying to decode the erasure positions, and Y is the variable node messages. The same in the initialization step, those are same. So these messages will be passed to the uh, variable to check node. Here the green line indicates the known values and the red line indicates the erasure. Blue, since there is only one connection from this node, it is indicated as blue. Okay. Now, round one is, once the variable node pass these received values to the check node, the check node has to compute the corresponding messages that is to be sent to the corresponding variable nodes. So how that, there comes the importance of the steps that we have discussed. Check node is computing the message by following the step, like if any of the incoming um, values is erasure, then the particular check node will send this as erasure. So here there is no need to send a value towards this variable node because this variable node value is already known. So this check node, considering the first check node, this has to think about this connection is also having a known value. This connection is also having a known value. So it has to consider only about the second variable node message, and this will be computed if all other incoming, um, if all other except this connection is having non values, incoming message values other than erasure, then the sum of those values will be sent to the sent to this variable node as message. So here the check node will compute this 0 plus 0 plus 0. So 0 plus 0 plus 0 is 0. This 0 message towards this um, variable node, and this 0 you can see here. Okay, and remember at that time parallelly these two check nodes should also compute some value based on the steps discussed earlier, and it has to send to the corresponding variable node. And when you think about this variable node, yeah, this is more uh, clear from this picture because when you think about this check node, this is having a known value, this is also known, this is erasure, this is erasure. So when this check node tries to send a message towards this variable node, all other edges are not having values, but instead this edge is having an erasure. So it will be sending um, the message as erasure itself. Similarly, when you think about this check node, so this won't be corrected in this step. And when you try to compute the message from the third check node, this connection is having 0 value. This connection was erased initially in round 1, and remember these check nodes are doing this parallelly. So you have to consider this value as erasure only. This is also erasure. This is one. So two erasures are there. So when this check node tries to send the message to this variable node, that will be erasure because the other one of the incoming edge is having erasure. So this is erasure only. So that is why at the end of round one, the check to variable node messages will be like this here x. Now variable node will pass this messages to the check node 0, 0, 0, 0. Okay, so this erasures like that. So now what happens is uh, based on this check node need not compute anything because it will just send the sum of uh, this is a variable to check node messages. Now we have to think about the round to check node to variable message transmission. So this first check node will be sending since all other connection has got values. So it can easily send the sum of the all other values as towards a particular variable node. So uh, that will be obviously 0 because here already known values there. Here also we have computed in the round one. Here also 0 known value. Here also 0. Now thinking about um, this particular node, check node, this connection is having a value 0. This connection is having a value 0. This is erasure. This is also erasure. So um, two erasures are there. So it will be sending messages as erasures only. But when it comes to the third node, there is a difference. Third node has connections from first node, second node, and this node and last node. So all these three nodes, 1, 2, 3, these three nodes are having values 0, 0, and 1 respectively. So there is only one erasure. So if this check node is having only one erasure, the message which will be sent to this particular variable node will be the sum of all other incoming edges. So 0 plus 0 plus 1, so 1. Obviously, at the round 2, the check node will transmit 1 to the variable node. So this is also being filled. And the variable to check node messages are nothing but this will transmit the messages to the corresponding messages to the check nodes. And now we have only one erasure to be found. So basically this check node got all the variable nodes connections, values corresponding to the variable node connections. Second check node now 1, 2, 3, 4. It has to find out only this erasure value. So basically the message that should be sent from this check node to this variable node will be the sum of all other incoming values. So this is 0 plus 0 plus 1. So 1. So this will be fed to uh, this check node will send the value 1 to this particular variable node. Now we have found out all the code word bits, and at that time the last check node all the connections have got values, so it's done. So this is the decoded code word. At this point, round 3. After round 3, we have received all the code word bits, and this is 0001011. So this is the code word bit, and if this code word into H transpose is equal to an all zero combination, then the decoded code word is correct. And this is obviously correct because one can think about H transpose like this position, this 0 plus 0 plus 0, 0, 1 plus 1 plus 0, 1, 0, 1 plus 0 plus 1 also 0. So we will surely get x into H transpose is equal to all 0, and uh, so the decoder code word is correct. So please keep it in mind that when you're asked to write the message passing decoding algorithm, you have to explain the last discussed thing, not the local procedure. Okay.